Thanks everybody for joining us. We're just going to give everybody a minute or two to jump online. Okay, I think we'll get underway. So thank you everybody for joining us for today's session and for giving us an hour of your time so that we can provide you with some information about Marinus Link and its proposed route in Victoria. My name's Mandy Davidson and I have the pleasure of chairing today's session. I'm joined today by three key members of the Project Marinus team: Ben White, who is the leader of Stakeholder and Environment Services, Stephen Clark, the Project Director for Marinus Link, and Barton Napier, who's a Senior Principal Environmental and Social Consultant with Coffee. The first part of today's session will provide you with an overview of Marinus Link, the proposed route in Victoria and why it was chosen. The formal presentations will then be followed by a Q&A session where Ben, Stephen and Barton will answer your questions. Before we start, I just want to run through some housekeeping to make sure that the session runs smoothly for everybody. Firstly, we ask that everyone keeps their microphones on mute for the duration of the session. We encourage you to raise any questions using the Q&A tool. As shown on the slide, you can access your microphone and the Q&A tool on the Zoom toolbar at the bottom of your screen. We encourage you to submit any questions through the Q&A at any time during the session, and we'll answer these after the presentations. We encourage you also to like any questions that are posted if they're similar to something that you had on your mind, and that'll let us know which topics to focus on during the Q&A. We'll try our very best to answer as many questions as we can, and we'll record all of the outstanding questions to follow up with you after the webinar. We are recording the session today and it will be made available on our website afterwards. It goes without saying that this is a public forum, so we do ask that everyone please be respectful and appreciative of others' viewpoints. I'll now hand over to Ben White.
Thank you, Mandy. Good morning, everybody. Thanks so much for making time for us to speak with you this morning and take your questions and queries on board. We value these opportunities to talk with stakeholders on an extremely important project that will deliver very extraordinary things. First, I want to acknowledge country and the Palawa people of Tasmania, on whose land I stand and a number of us here online stand. I also acknowledge the Gunai people of the North Gippsland region, on whose land we will largely speak of today, but also acknowledge the First Nations people of the various lands and waterways that we gather today, recognising that there's a number of people on this webinar that are gathered across the country. So thank you again for your time, and it's a pleasure now just to give you a high-level overview of Project Marinus and Marinus Link for everyone's benefit. The first starting question obviously is, what is this project and what's its need? And I guess we are all experiencing rapid transformation, particularly of our national energy market. The national electricity system was built around thermal generation largely in the past, around coal and gas, with transmission developments that connected those resources to customers. We're now seeing this transformation into large-scale variable wind and solar resources as our lowest cost form of energy development. And we are needing to connect to those new resources, which are generally located in different places. But the exit of thermal generation, and you can see in this slide the coal generation profile across the national electricity market by 2040, in what the Australian Energy Market Operator deems as a central case scenario, so a business as usual kind of case scenario, we're going to see around 19,000 megawatts of coal retiring by 2040. That's an extraordinary level of capacity that will be coming off the system. That's akin to almost the same amount of energy demand across New South Wales and Victoria combined. That will be replaced ostensibly by this new form variable renewables in wind and solar of around 32,000 megawatts. Noting this isn't like for like replacement. They're different generation types with different levels of variability and reliability of supply. So that variable renewable energy needs to also be paired with or firmed up by at least 12,000 megawatts of dispatchable resources. So that's often in the form of storage, and we've got a whole variety of storage options with batteries playing a key part. The need for what we call deep and long duration energy storage, which pumped hydro energy storage is an option for that. And also gas, there's a role for gas in that dispatchability. So that just gives you a broader sense of the need, what's driving the change, and this is where a project like Marinus Link and the things that it connects to and unlocks has to offer. The graphic here just gives you a broad overview of the geography by which Project Marinus is undertaking now in the design and approvals stage. We undertook a detailed feasibility assessment, and we also did a business case assessment with a report released in late 2019. That's now precipitated the next stage of works. You can see in the map, we'll largely, as Mandy indicated, be focusing on the Victorian side, that land component, but you can see it is a big component, but the stretch of all that's involved with Project Marinus, both Marinus Link and what we call the Northwest Tasmanian transmission developments, it's upwards near 600 kilometres of linear infrastructure development. But when we talk about Marinus Link, it is a 1,500 megawatt transmission interconnector between Tasmania and Victoria. It also carries with it optical fibre capacity. So not just for electricity, it's also increasing our capacity for telecommunications. We're very fortunate with this project to have broad support across the different jurisdictions that are related to this project at local, state and federal level, with funding support by the state of Tasmania and also the Australian government. Through the Australian Energy Market Operator as the national planner of the transmission network, also Victoria's jurisdictional planner for transmission, we seeing from AEMO that Marinus Link is a critical project, an actionable project that was raised in the most recent integrated system plan of 2020. And for the third year running, we are seen as a high priority initiative from Infrastructure Australia, and we're very fortunate to and welcoming the indication from Infrastructure Victoria as being part of the future infrastructure picture for the state. So Marinus Link, as indicated, is an enabler for this transition. We are seeing the opportunity in what Tasmania has to offer the rest of the national electricity market in the vast, low-cost, reliable and clean energy resources that the state in Tasmania has to offer. We can see in this diagram on the top left, wind, particularly here in Tasmania, is bringing with it capacity factors that are very, very impressive. We're seeing 25% higher output than other comparable places across the NEM. We're also seeing the opportunity for pumped hydro energy storage, noting that Tasmania already has excess supply of hydro resources. With pumped hydro storage at low cost, we can get that into the marketplace. And having that dispatchable on-demand energy, particularly noting high demand peak periods on the mainland tend to occur in summer. whilst the peak in Tasmania, being a much smaller peak, occurs in winter. So there's a great level of compatibility, and also the exchange with Marinus Link means we can store excess renewable energy supply and generation from the mainland in Tasmania and send it back when the market requires it. What does this mean in terms of broader economic contributions? So we will hopefully touch some more on our panel session around the cost benefit analysis to a degree, but this is an expression of what other economic development opportunities does a project like this provide. And in Victoria, the work and study we've done has identified at least $1.5 billion of direct economic investment in particularly the Gippsland region, and over the course of the construction phase, the peak construction period, we're seeing around 1,400 direct and indirect jobs for that Gippsland region. So a massive opportunity just with Marinus Link in its own right, let alone everything else that it unlocks. So we are driving very hard and very committed to working with stakeholders around regional and local procurement, getting content and local businesses involved. We want this story to be a successful story, and looking at past developments, the things we can learn and do better. The employment and workforce planning opportunities are also there. And again, these are long lead time projects. The conversations are started, and we want to keep having the conversations about getting ready to gear up the skills base and workforce base to contribute to this project, particularly from the Gippsland region. And the significant flow-on benefits and community benefits that come from this project. Just quickly, this is a high-level working timeline. We are entering, if you can look down the bottom part, different stage gates or decision points of a project of this nature. We are entering the end of the establishment phase. You can see there, which is about to commence then into what we call our tendering phase. So there are a number of stage gates through the broader design and approvals phase. We hope to reach a final investment decision in the financial year of 2023-2024, and then from that point we would commence construction and look to build Marinus Link in 2 stages, so 2 750 megawatt stages. So the business case has established, and together with the Australian Energy Market Operator, seeing the need for the first stage of Marinus Link needing to be built and in service from 2027-28, with the second stage built and in service 2 years after that. So that's the timeline we're working towards. It's ambitious, it's a big project, and we have a lot to work through. Talking to stakeholders like forums today, together with landowners and the broader community, is an absolute essential part of this work, and we really do look forward to working with you. And I'll hand now over to Bart Napier, who will take us through in more detail the route selection process, noting today we are working towards releasing a detailed route options report for you all to look at, but this is the opportunity to take you into some more of that detail today. So over to you, Barton. Thanks.
Thank you very much, Ben, and good morning, everyone. What I propose to do now is take you through the route selection process for Marinus Link and explain how we have got to the proposed route that was released in December 2020. So the first thing we start with route selection is what connection is required. And obviously Marinus Link is a proposal to connect the Tasmanian and Victorian electricity grids together to enable, as Ben has explained, the export and import of energy across Bass Strait to facilitate the transition to renewable energies within the national electricity market. It will also, as Ben said, utilise the vast dispatchable generation resources available in Tasmania, particularly from its hydro developments, but also from its planned pumped hydroelectric storage developments. In order to connect Tasmania to Victoria, just as was the case when Basslink was proposed, we need to connect the strongest nodes in the two jurisdictions. In Tasmania, that's the 220 kV or 220,000 volt network, as you can see there in the blue concept lines for the transmission network in Tasmania, and in Victoria it's the 500 kV and 220 kV networks, as you can see in Victoria. The reason we need to connect at these voltages is that, as Ben has explained, Marinus Link is a 1500 megawatt interconnector, and in Tasmania, which has an average demand of 1100 megawatts, that's a significant load. And so we can't connect at lower voltages or we place too much strain on the networks. Victoria has greater capacity to cope with that, with an average demand of around 6,500 megawatts. And so Victoria's system is a bit more robust in that sense. And again, we still need to connect at either 220 kV or 500 kV. As you would expect with linear infrastructure, the shortest overall distance is preferable. All linear infrastructure ultimately equates to a unit cost per kilometre, and so the more kilometres you add, obviously the dearer or more costly the project gets. We have chosen on this occasion to make physical separation from Basslink. It is technically feasible to run along parallel to Basslink between Tasmania and Victoria, but for system security reasons, it's prudent to be geographically separated from Basslink. And we mean by many kilometres, not just by a kilometre or hundreds of metres. And the reason for that is to protect against such events as a container ship or other vessel dragging its anchors across the cable and damaging them. And there are instances in Europe where that has happened, with multiple interconnectors affected when they were laid in close proximity. It also protects the interconnection from natural disasters such as bushfires or other events, storm events that might interrupt the interconnector. The other important factor that was taken into consideration in not considering Basslink on this occasion, it could be possible for future interconnectors, is the proximity to the available renewable energy resources in Tasmania. And at the moment, all of the proposed and potential developments are mainly focused in the northwest of Tasmania, which is onshore wind, and in the West Coast and Merseyforth schemes where there is pumped hydro electric storage being investigated by Hydro Tasmania. So for these reasons, it's prudent on this occasion not to follow Basslink. So what is proposed to be built? As Ben has explained, it's a 1500 megawatt HVDC, high voltage direct current interconnector, to be built in 2 stages. Direct current is chosen, not alternating current in this instance, because alternating current has much higher losses than direct current, particularly when you're transmitting over very long distances. And Strait poses a technical constraint for the use of AC technology, which if we were to construct Marinus Link using AC technology at the voltages that are proposed, we would need to have boosting stations or reactive plant, as it's technically called, approximately every 20 to 30 kilometres to maintain the voltage. And as you'd appreciate, that's technically not particularly feasible through Strait. So the reason Marinus Link is a direct current interconnector is, as I said, a combination of distance and technical issues. Marinus Link will be using voltage source converter stations to transform AC or alternating current into direct current and vice versa. Basslink uses line commutated converter stations, which was at that time a robust technology and still is, but recently voltage source converter stations have become more technically feasible and offer greater advantages over line commutated converter stations. We will be connecting the converter stations in Tasmania and Victoria by subsea and underground or land cables. And the reason for that is that it's prudent to do that, given that we have large sections of underground cables, subsea cables through Bass Strait, and there are some technical issues associated with overhead underground line combinations when using voltage source converter stations. We will require switching stations to connect the voltage source converters back into the Tasmanian and Victorian transmission networks. The subsea cables that will be laid across Bass Strait will be laid on the seabed and then buried in the seabed to protect them. The land cables will be buried in trenches and protected by easements approximately 20 metres wide. We will require what we call a land-sea joint or transition point at the coast to join the subsea cables to the land cables. And then on land, we will require joint pits approximately every 1,200 metres to join the cable links. The graphic you see at the top right there depicts what I've just described, and the image below shows a conceptual arrangement of 2 converter stations, one for each 750 megawatt link arrangement, which is typically what will be built in Tasmania and Victoria. The first thing we do when we look for routes is to consider the constraints and opportunities. There are constraints in the Victorian transmission network that we'll talk about shortly, and then the more obvious constraints around national parks, marine parks, etc., cultural heritage, conservation reserves, including coastal reserves. We have Ramsar wetlands either side of Wilson's Promontory, and in Western Port Bay, we have some topographic and terrain issues associated right along the north coast of Tasmania and along the southern coast of Victoria. There are pockets and tracts of biodiversity comprising native vegetation supporting threatened ecological communities and species, and obviously land use constraints, including intensive agriculture, plantations, urban growth, and rural residential development. We also look at opportunities and existing infrastructure corridors, for example, Bass Link and roads provide opportunities where practicable, and obviously unmade government road reserves where they may or may not be required for future roads. Just highlighting some of these constraints and opportunities. On the left, you will see the same network map that we had before, network schematic, and you'll see that the transmission lines from Haywood in Western Victoria near Portland to Moorabool are becoming increasingly constrained. This is a result of the considerable development of solar and onshore wind in Western Victoria and Northwest Victoria. And so that transmission line through there is expected to become highly constrained in the not too distant future. The transmission lines, the 220 kV circuits from Moorabool through to East Geelong are already highly constrained and would require significant upgrade or replacement to enable transmission through that corridor. On the other side of Melbourne in Western Port Bay, Tyab is similarly constrained. It's highly constrained from an electrical perspective, but it's also highly constrained from land use and urban encroachment. And so when you take that into, those constraints into consideration have a significant bearing on route selection. The figure on the right shows the national parks, coastal parks, marine national parks along the Victorian south coast. And as you can see, there are quite significant areas of the coast which are unavailable for landfalls and for bringing an interconnector across Bass Strait. In terms of Bass Strait constraints, obviously fisheries are an important consideration, particularly where the installation of a cable in the seabed may preclude some fishing activities. There is significant oil and gas exploration and production facilities in Bass Strait and pipelines connecting those back to the mainland. There are a number of defence training areas and disposal grounds where ammunition cases and spent rounds were dumped in the sea. There are a number of telecommunication cables and obviously Bass Link, the other interconnector. And that, as you would expect, given the history of Bass Strait and early settlement, there are a lot of shipwrecks and some ship graveyards. The figure on the left shows you the different types of fishing activity that occurs in Bass Strait and where it occurs. And as you can see, it's mainly focused along the island chains to the east and west of central Bass Strait, along the margins, as we call it. And this comprises shark fisheries, scallops, abalone, trawl netting, and along the north coast of Tasmania, aquaculture. On the right, you'll see a figure showing the oil and gas developments in Bass Strait and the connecting pipelines along with Bass Link. The shaded areas comprise defence training areas and disposal grounds and other exclusion areas. Having considered all of those constraints and opportunities, we identified some prudent and feasible corridors across Bass Strait. And they are shown in the figure on the right and described on the left as Port Latter to Portland along the western margins of Bass Strait. Port Latter to Moorabool, the most direct route from Port Latter via East Geelong. Burnie to Moorabool via East Geelong. And then obviously Burnie to Hazelwood, Sheffield to Cranbourne and Sheffield to Hazelwood. And there are obviously a number of other permutations and combinations there, but the reason we've identified these corridors is that they represent the shortest potential links between those major nodes on the Victorian transmission network and from the Tasmanian network. In considering and identifying prudent and feasible routes, we took into account the route and site selection criteria that were prepared for the project. And they included things like avoiding conservation reserves, adequate separation from houses, consideration of land use, avoiding biodiversity values, particularly threatened species and habitat where possible, cultural heritage, both Aboriginal and historic, land use considerations around agriculture, forestry, aquaculture, etc. Landscape and amenity, particularly in relation to the converter stations, but also in relation to some sections of the underground on-land routes where they might involve extensive clearing of vegetation. Landslip and erosion hazard areas, both in Tasmania and Victoria. Terrain, geology and landforms have significant bearing when you're proposing underground cables because we cannot overfly some features as we can with overhead transmission lines, which is a significant advantage of overhead transmission lines. With underground cables, we need to basically traverse all of the geological and technical and other features along the route. And obviously we took into consideration constructability issues and operation and maintenance issues in selecting and identifying the routes. We then evaluated the routes that were shown in the previous slide, and it was obvious, as you would appreciate from that, that the Tasmanian network west of Sheffield is not as strong as necessary or required to support Marinus Link. And Tas Networks has been doing considerable work and identified that the existing network needs to be upgraded to address some existing network constraints. But it also needs to be upgraded to enable connection of renewable generation projects in northwest Tasmania and in the West Coast, and Merseyforth schemes in Tasmania, and obviously to support Marinus Link. As part of its planning obligations, TasNetworks undertook what's called the Northwest Tasmania Strategic Transmission Plan to basically identify the future transmission augmentation and needs to support the development of the renewable energy zone and enable those projects. And that concluded that it was prudent to extend the grid backbone from the backbone that's provided by Palmerston, Sheffield and Georgetown, just out of picture here. That is the current grid backbone, the strongest part of the Tasmanian network. And the studies concluded that it was prudent to develop another backbone, a rectangle here, from Sheffield through Staverton, across to Hampshire and back to Burnie, and upgrade this network to support all of this development potentially coming out of this area. My apologies. Could you? Oh, sorry. And also to support the connection of Marinus Link through Burnie here. In considering or evaluating the prudent and feasible routes, it was done at multiple levels, and the first level is strategic. And obviously the Northwest transmission upgrade that are occurring is one of the strategic considerations. The other one was, where is the least constrained part of the Victorian network? And as you would appreciate from the previous slides, that Hazelwood is currently unconstrained, as was Cranbourne and Loy Yang. And so they offer the best opportunities to connect into the Victorian network. Hazelwood, with its 4 circuits back to Melbourne, offers the greatest flexibility and was the reason that was chosen. And subsequent to TasNetworks identifying that as the strongest connection point, AEMO has confirmed that Hazelwood is their preferred connection point. When we then looked at what we call tactical constraints and issues and evaluated all of the route selection criteria that we previously spoke about, the other routes came out more constrained for different reasons, but overall they came out more constrained, and the route that was identified as the least constrained was the route from Burnie through to Hazelwood. It's, oops, sorry, my apologies. As it explains there, this is the shortest distance between the strongest and least constrained nodes on the Tasmanian and Victorian transmission networks. It's the least constrained route overall, having regard to biodiversity, land use, topography, and other issues that were encountered on the other routes. It results in the converter stations being on the coast near Haybridge, just east of Burnie. It adopts a line of longitude 146.05 across Bass Strait, similar to what Basslink does, and that improves the opportunity to alert mariners to the location of the cable rather than it wandering around. It's a very clear position for them to understand where it is and avoid dropping anchors over it or other issues, activities. The subsea cables for each stage will be laid 2 kilometres apart in Bass Strait to basically increase or reduce the risk of both cables being damaged. At Hazelwood, the converter stations will be either near or at Hazelwood. And as we said, the Victorian route is addressing some significant topographic constraints, as did all routes coming into Victoria. And the topographic constraints we're talking about is the Strait ranges here, which extend from Western Port right through here, through Carajung into Gormandale over here. And as you can see, this is the relief of the Strait ranges, very mountainous in places, particularly around south of Warrigal, Trafalgar, through that area there, and again through Baluk and the Tarabulga National Park and Budgeree through here. It's very steep mountainous country in places. This is the Tarwin River Valley here, and this is the Maul River Valley here coming up into Ballara. And as you can see, this is the shortest distance across the Strzelecki Ranges. And so when we were looking at route opportunities to get to Hazelwood in this area, or into the Hazelwood area here, and with obviously the shortest distance across Bass Strait being Waratah Bay here, we were then looking to basically run up through this Tarwin River Valley as far as we could and get across into the Latrobe Valley, across making the shortest crossing of the Strzelecki Ranges. You might appreciate that this is the shortest crossing, and we'll discuss that in a minute, but when you consider it, both options have a similar exposure to the Strzelecki Ranges. So having identified that Burnie Hazelwood was the proposed route for Marinus Link, we then went into further detail in examining that route, that initial conceptual route, to ensure that we had considered all prudent and feasible alternatives. As I've explained, the land cable routes are constrained by topography and terrain. And so we investigated options of running further up the Tarwin River Valley, up into the Merbu limonite area, and then crossing across there into Ballara, as shown on the previous slide. And we also looked at numerous options of trying to get up the southern face of the Strzelecki Ranges, which are thank you, which are steeper and a little bit more problematic than the northern slopes. In looking at those options, we looked at the road network in detail through that area to see if we could utilise the road network. But practically, it's technically not practical in a number of places because it's single lane in places, particularly around limonite, where we cannot use the road or couldn't use the road. The adjacent land infrastructure, watercourses and steep gullies make it very highly constrained. The other issue with using the road network is that we cause significant traffic and access disruption as we're constructing along it. And so to try and overcome these things, we focused on trying to utilise common and back boundaries where we could, right through there, but also against the road boundaries and that where it was prudent to basically try and keep the route out of the middle of paddocks. And so having examined all of those, we concluded that the conceptual route that was first developed was indeed the least constrained route based on the information we had at the time. So what are the next steps? Having identified the proposed route, Tas Networks is now engaging with affected landowners and land managers. We're working through a process of reviewing the route with them and what it means to them and how it affects their properties and businesses. We're seeking access to survey the proposed route to better understand the biodiversity values along it, to better understand the Aboriginal and historic cultural heritage values along it, and also to undertake geotechnical investigations to confirm the constructability. We will review the route and refine it in consultation with landowners and land managers. And then it will be taken through the environmental and planning approvals process, which will take approximately 2 years and provide further opportunities to comment on the route and its impacts. As a result of technical studies that will be conducted as part of the environmental and planning approvals process and further engineering investigations and discussions with landowners, further route refinement may result from that process. Thank you very much.
Thank you very much, Barton and Ben, for your presentations, and apologies for the screen gremlins. If I can invite our three panelists back onto the screen now, and I'll stop sharing those so we can see you. And we'll have some questions. So Stephen, if you can please join us back on the screen, because I think the first question will be for you. There were a couple of questions there that I think recognise that there are other projects going on in Victoria right now. Can you tell us from the perspective of Marinus Link why you've chosen underground and not overhead, and what are some of the differences in costs and technical considerations for those?
Okay, so there's a number of reasons we looked at underground versus overhead. We looked at both of those issues for us. When it came to the comparison, though, what we found is that there are a number of constraints that mean that underground can be built easier. We didn't need a narrower easement, for example, and less cables. But we also looked at the cost of the options as well. If you actually build overhead, then what the initial overhead impact is going to be wider easements, and the initial cost, depending on where you have the converter station, is about the same cost as going underground for us. It's a different story, I think, for other projects in Victoria, other projects that, because for us, we've already got the converter stations, we're already starting the cable going across Bass Strait. So the incremental cost to keep going with cable is less than if you went from scratch with converter stations and cable.
Thanks, Stephen. Barton, there are also a couple of questions in our Q&A about the route, and noting to those listening, if you still have some questions, there is still an opportunity to add them into the Q&A. Barton, why doesn't the route run directly from Waratah Bay to Hazelwood? And was the route selection done just by desktop, or was there actually a walkthrough undertaken?
So the route selection was done off desktop information using all publicly available information. And then once we'd identified potential routes, they were inspected from the public road network to verify that they were indeed feasible and that we hadn't impacted on houses or other developments that were new and not picked up in the imagery. And the reason we didn't go directly from Waratah Bay to Hazelwood is, as I explained in the slide that showed the topography, is that the topography around Foster and up through behind Foster through to Murby North is extremely steep and challenging, as opposed to running up the Tarwin River Valley to as close to the stress eckies as we could get. Thank you, Mandy.
Thanks, Barton. Ben, there's some interest in how the project might support wind farm development in Victoria. Will there be connections to wind farms in Victoria, and particularly to proposed developments in the Delburn area?
Hello, Mandy, can you hear me? Sorry, my internet is...
Yes, we've got you. Thanks, Ben.
Okay, great. I think I gathered the question. The Marinus Link, whether it directly supports or connects wind developments in the Gippsland region, is that the broad question?
Yeah, that's correct. Will it support wind farm developments in Victoria, and in particularly in the Delburn area?
Yeah, look, sure. Just to go to the latter part of that question, and building on Stephen's response to the use of direct current and alternating current. So we are looking to run Marinus Link as direct current from Tasmania all the way into the Latrobe Valley, purely because we aren't planning to connect any generation projects on the Victorian side. So that's the most cost-effective and efficient way to move large bulk amounts of energy over large distances, is to run that DC right through. So you don't connect new wind energy developments to direct current cables. You need alternating current technology for that. So that's just the first direct response to that. So we're not contingent on, nor are we planning to connect projects like the Delburn Wind Farm or Star of the South to Marinus Link. However, Marinus Link, as I was describing earlier, it's an enabler of the transition, but it's also a two-way energy flow. So where wind developments or solar developments right across the national electricity market may produce excess energy rather than curtailing projects, so turning wind farms off or turning solar farms off, that excess energy can be sent south through Marinus Link, stored in the pumped hydro facilities that are being planned and proposed in Tasmania. So it's basically a big water battery, if you like, and then released again back to customers in those peak demand periods when they need it. So that's the general logic. So quite directly, we don't connect new projects, but generally speaking, we support the commercial productivity of other projects.
And Ben, probably a good follow-on to that. What work is the team doing to examine both the economic benefits but also economic costs of the project in Victoria? And then perhaps, Barton, could you talk about the next steps in terms of the environmental effects statement and how you go about determining the final route?
Sure, thanks, Mandy. Great question. Thank you for that, who posed that question. So there's different streams with a project like this and a number of regulatory processes we have to go through. One is a cost-benefit analysis through what we call our regulatory investment test for transmission. So that's governed by the Australian Energy Regulator. So that's putting energy customers' interests at heart there. So we have to look at a whole range of alternatives counter to Marinus Link, if you like. What are the other solutions that might be available that can deliver the best benefit to customers in the most cost-effective way? But the work we've done actually sees Marinus Link stacking up against a whole range of other options under a whole range of other future scenarios. So that's that part. We look at the additional economic development opportunities, as I briefly touched on, in terms of direct investment, jobs and workforce creation, skills development. But I guess at the heart perhaps of this question, how else do we factor the impact and the costs on communities, businesses, and also the environment and cultural heritage values? So that part of it is done through the environmental impact assessment, which has a social impact assessment dimension. So that takes into a whole suite of things like impacts on that regional and local economy, impacts on tourism, impacts on landscape values, cultural heritage values, and then we do the environmental or ecology impact assessments as well. So very rigorous and long sort of process for that. Lots of opportunity for community, landowners and other stakeholders to have their say in that process. So we take that really seriously. We want to be a model proponent and do this well, but we need to do that very carefully and respectfully with our range of stakeholders.
And just to answer the second part of the question, in terms of the environmental and planning approvals process, the next steps and the first steps are to prepare referrals. So we'll be referring the project under Victorian legislation under the Environment Effects Act. We'll be referring it federally under the Environment Protection and Biodiversity Conservation Act, and we'll be providing notification in Tasmania under the relevant acts there. And those referrals will enable those governments to determine the appropriate level of assessment for the project, which we anticipate will be at the level of an environmental impact statement. And so once that is confirmed, we will prepare an environmental impact statement, which will encompass an extensive set of studies, including ecology, biodiversity, land use, planning, transport, etc., which will be published and available for public comment through the submission process that comes at the end of the work that we do. And so there'll be a number of opportunities through that process to receive updated information as we progress the approvals process, but also an opportunity at the end of the approvals the submission of the documentation for you to submit, make a submission on the work that's been done, and to participate in any hearings that the governments convene to look into the approvals and the project.
Thanks, Martin. There are a couple of questions relating to landowners and land use. Firstly, somebody is asking why landowners don't have this level of information already. Ben, perhaps you can help on that one, and also on the question of whether or not the easement land can be cultivated or cropped once the cable is laid.
Sure, great, thank you. Great questions. So what we've provided to date we have land agents who are skilled, experienced, qualified, working with landowners as readily as possible. We've provided landowners with a landowner pack, which we hope provides a number of points of clarification and the purpose and some of the activities that we plan to do on the proposed route. So that's a piece of information that's there, but we appreciate, documents and pieces of paper. Not everyone's got the time to look at those and read those. So we encourage landowners who might be participating in the call today to continue to work with the land agents, but also with us directly if you're not getting the cut through you need. We're here to really listen and support that. When we announced the proposed route late last year, we also provided what we call a route options overview report. So apologies for the lengthy title of that name, but the overview just gives you a broad sense, a bit about what we've talked about with you today, how we've come to pursue a project like this, right through to the methodology for selecting the proposed route. And today is an opportunity to talk further with you about that in a little bit more detail. And as I mentioned earlier, we'll be releasing a detailed route options report for stakeholders to really dive deeply into a whole range of factors that were considered on each route option. And as Barton's outlined, some of those values and constraints that were detailed in that, and some of the other factors which were technology and configuration options in there as well. So we hope there's a sufficient level of information at this stage, but we appreciate lots of questions, great questions. We want to be available as readily as we can to answer any of those. So I hope that's that particular question answered to a degree. Now, what can happen on the easement once it is a declared easement? Remembering we're still in the early stages. We've proposed a route. We want to work with landowners and the community around that proposal. We're working and listening with a number of landowners now around some adjustments that might be made to get to what we would then call a preferred route, which is the route we would take forward in terms of our impact assessment and other activities like survey works and potentially easement right negotiations in time. So let's look at the proposed easement width. It's approximately 20 metres in total. So Marinus Link, as two sets of cables, sit within trenches below ground. So what we're seeing all come to pass, landowners can largely continue to use that land. So if you're a farmer, and I'm a farmer from Victoria, growing up in a farming family, I know how important it is to continue the viability and productivity of your land. You can continue to graze, you can continue to irrigate, you can continue to crop as well. Really, the constraint is the fact that the cables sit close to a metre below surface, or about 0.9 of a metre. So borehole drilling for groundwater or deep sort of boreholes for fence posts are prohibited, and other activities like permanent structures, tree planting, they're the kind of prohibited things. But otherwise, on the surface, you get to continue to use that land in a productive way.
Thanks, Ben. A couple of technical questions heading your way, Stephen. What area does a converter station take up, and do you have any idea at this stage about the cost of the converter station specifically?
So the main converter building, which does the conversion from DC to AC and back again, that's approximately 100 metres by 50 metres. And then we need land around that for all the other buildings and supporting infrastructure, about twice that size for each converter. And we're looking at having 2 converters in Victoria and 2 converters in Tasmania. So that sort of gives you a bit of a sense of the size of buildings. Each converter is around about $200 million cost.
Thanks, Stephen. And also, we have somebody asking about the construction of the project, noting that stage 1 and 2 are separate. Is this necessary, and does that mean that for the underground component in Victoria, the trench will need to be redug for stage 2?
So in terms of the staging, there's I suppose potentially necessary and beneficial to stage it. So the cable production is going to take mobilise a couple of factories to actually produce the cable. So it would struggle to actually get one factory to produce all the cable we need for both stages in one go. So staging that makes it a bit easier. But also when we look at the economics of the project, that we don't need, and the national electricity market doesn't need the full 1,500 megawatts in one go. Staging over a couple of years better matches the capacity that we're building with the demand for that in the market. In terms of staging of the actual trenching, we're looking at that question at the moment. So exactly how best to manage that.
Thanks, Stephen. And we've got time for one last question also to you. In terms of where the cable comes ashore at Waratah Bay, we have somebody asking whether the pipeline depth will be 0.9 metres below the shoreline, and is that sufficient in terms of protecting the dunes and the foreshore there?
Okay, so we use a different approach in the shore crossing. So the 0.9, that's the top of actually the cable markers. So the trench actually goes a bit deeper on shore. But when we come to the dune areas and the beach, we're actually going to use horizontal directional drilling, and we'll be going a lot deeper than that. We don't actually have exact figures yet because we need to do the detailed design for that, but it's several metres below the surface of the sort of beach, for example. And we're looking at sort of coming out almost a kilometre offshore. So the cable will be well and truly out of the way of the beach, and we're protected from surf action and moving the sand moving and so forth.
Thank you. And thanks, everybody. That's all we've got time for today. I'd like to thank everybody who has attended today's session, and I hope you've learned as much as I have about Marinus Link and the proposed route in Victoria. The team has recorded your outstanding questions, and we'll email responses to everybody who's registered for the webinar after the session. I would encourage you to visit engage.marinuslink.com.au. I'm just going to share some contact details for you again so that you know how you can get in touch with the team should you wish to do that in future. Just bear with me while I share my screen. There we go. So you can contact the team there via the website, email, or via the telephone number that's on the screen. We do currently have an interactive map that's available on our website to enable the public to provide feedback on the route through Victoria. And this information is going to be helping us to refine the route through that area. We'll also be sending out a survey after today's webinar, just seeking your feedback on how you found the webinar format and the way that ran. And also how you wish us to engage with you in the future. So once again, thank you very much for joining us, and enjoy the rest of your week. Goodbye.